So let's go through the last two looping constructs that Java provides for us. We have the while loop and the do while loop left for us to cover. So we'll start with the while loop and then proceed to the do while loop. I'll bring up my NetBeans here and I'll just push all of what we did earlier down, and I'll create another method here. I'll say public void test do while loop. Sorry, test while loop, not the do while loop. We'll start with the while loop. Remember, when you want to name a method or a variable when using identifiers, you need to be careful there. You're not using one of the Java keywords. All right. So inside this method, what I'm going to do is I'm going to declare a variable char. You could call it char, anyone. For me, it works. Letter is equal to, and I'll put the character A. And remember, characters are always single quoted, while strings have double quotes around them. Then I'm going to declare a variable here, int x, and down here I'm going to write my while loop while x is less than or equal to int. Okay, let's count from, let's do the same thing we did earlier. For example, it's less than or equal to 10, or let's count from 1 to 20. Then I'll get inside here and I'll print out the value of x, system.out.println, and I'll say x plus some space. I'll print it on the same line so that we don't have to scroll to see the result. And then, so I'm just printing x and some empty space, and I'll initialize x here to 1. Remember, local, you cannot use a variable in Java without initializing, and local variables never get initialized by default, so you must initialize them. Then down here, I'm going to put a test condition, a reinitialization to change the value of x. I'll say x plus plus. All right. Now, like all the other constructs we have seen so far, the while loop has the while keyword. It has a set of parentheses like this, and you have a test condition inside this parenthesis, and then you have the body of the loop, which is defined by the opening and the closing curly brace. Now, remember we said if you have just one statement controlled by this loop, for example, then you don't need the curly braces. So in this case, I have two statements. This one and this one are being controlled by the loop, so I must wrap it up inside the curly braces there to define the start and the end of the loop. And what's actually happening here is when this starts running, look at what I'm doing here. I'm creating a variable letter and I'm putting the character A inside. The variable is of type char, and here I have a variable that I'm going to use to construct my loop. When we saw the while loop, it had an initialization part and a reinitialization part, but the while loop, that was for the for loop, but the while loop just has this part here, the test condition. So we must first of all look for a way to initialize whatever variables we have to use in this test condition outside here. And what you get from the test condition must always result in a boolean, true or false. Otherwise, you have a problem. Your program will not compile. Then down here, since the loop also has no way to reinitialize, I must do something inside the loop to make sure that this condition fails at some point. Otherwise, it's going to loop forever. It's going to keep on looping and looping and looping and looping. We saw an example of an infinite loop when we ran the for loop. So it's going to keep on running. So to stop that, I change the value of x every time I loop. So let's see what's happening. Okay, I would comment this out. I'll use it later. Let's first of all count from 1 to 20. That's what we are doing. You're not using this letter yet. So I'll run this. I'll say while x. What happens is we say while x is less than or equal to 20. What's the value of x? X is 1. So is 1 less than 20? This statement is true, and then we print this out, and then we increment the value of x by 1, it becomes x plus plus. So x plus plus, x becomes 2. After this statement, x becomes 2. Is 2 less than 20? Yes, we repeat the same thing. We increment x, x becomes 3, and then we do the test again. So every time the while loop executes, after the body of the loop goes back to do the test, test the condition to see if the condition still holds true. If it holds true, it enters. It's going to loop until the point where x becomes 21, and then it's going to test the condition, and the condition will fail, and at that point it's not going to get into the loop, but it's going to jump directly to the end and say maybe system.out.print. I'm going to print an empty line there, and then I'm just going to print some message out. I'm going to print we are done. Good. So now when I run this, I expect it to count correctly from 1 to 20. It's not, I've not called my method. So I do jt dot test loop. I declare a variable and I call that method there. I create an instance of the class and I call the method on it. And now let me run it again. And I have it there counting from 1 to 20. What you need to know here is when the while loop starts executing, first of all, it has no initialization path. So you must initialize whatever you have to use inside here. So I'm initializing x to 1. And after that, the while loop starts. The first thing that happens is there is a test. It tests x against 20 and sees that x is less than 20. So it gets into the body of the loop and then it increments. Remember, if you don't do this, then when it will hit this curly brace and come back to the test condition, x will still be 1. So it will keep on looping. So every time you want to make sure you have something that's going to make the condition to fail at some point. In this case, this is what makes my condition to fail when x becomes 21. So you do the condition, execute the loop, you finish, you go back, you test the condition again. If it's true, you execute the loop. You go back, you test, you execute the loop. It goes back, test, execute, until when it tests and it fails, then it jumps directly. At that point, the loop is no longer executed, and that's the end of the loop. I think we could make this a little more interesting. That's why I put letter here. Let's print out the letters of the alphabet from A to Z. Since we said earlier that the character can also be used as, it's some form, it can be treated as an integer. Let's actually see how that works here. So I'm going to print the letters from A to Z, the uppercase letters. All right. Now, let's go back up here and see what's happening. I declare a variable letter of type char and I put A inside it. Letters are surrounded by single quotes, not double quotes. Once you put a double quote, it becomes a string, no longer a letter. Like this one here is an empty string, this one here is another string. You see it's in double quotes, while the character is in single quotes. Then I declare a variable x. That's what I'm going to use to control the looping. But I'm going to change this since I have 26 letters of the alphabet, and I'm going to loop right to 26 before breaking the condition. Alright, then here what I'm doing is I'm printing the letter. But after I print the letter, I need to do something. How do I shift to the next letter? I'm going to declare something here. I would say, okay, I'll write it in full. Then, let me write it short. We see it then later on. I'll write it in full. I'll say letter is equal to, or letter plus equals 1. If I run this, I expect it to print all the 26 letters of the alphabet. You see, I have A, B, C, D right up to Z. Alright, to make this clearer, I'm going to comment this out. I'm not going to use the compound assignment operator there, and I'm going to write it out in full so that you actually see what's happening. So I say letter is equal to, I'm going to cast something here. char, and then I'm going to write all of this. I'll explain. Plus 1. Letter has 2 T's, not 3. All right. Now what's happening here? In Java, we have something known as promotion. We're going to see what that promotion is in this case. Later on, we'll talk about it again. But for now, I'll just mention it a little. So, remember I said you can use character. The character is some form of an integer. It has 32 bits. And we all know that the letters of the alphabet, or the different characters that we have, different possible characters that we have, are represented internally by some code. For example, the letter A has the code 65. And what is happening here is, at this point, I'm saying letter plus 1. Letter is actually A. It contains A. But because I'm using it with an integer, it gets promoted to an integer at this point, and then the code is used. At this point, the code is 65. So 1 is added to 65, and we have 66, which is the code for letter B. And then because this is 66, it's actually an integer. And I cannot store an integer into a character because an integer is bigger than a character. So I forcefully cast that back into a character. So I say, okay, take the letter A, extract the code, which is 65, add 1 to it, because if A is 65, I mean, it's logical that B should be 66 and C should be 67. So I say, take the code 65, then add 1 to it, you get 66. Then convert the 66 back that you have to a character by doing that. And when I do that, it turns it back into B, for example, and it stores it here. Then I increment again, and I keep on going through the loop, and that's what happens. So if we print this out, we should still see that happening. We still have the same thing. So that's what is happening here. We are incrementing this, like converting this, extracting the code, which is 65 for the first time, adding 1 to it, it becomes 66. But don't forget, before doing that, we have already printed A, and then we store the result B inside here, and we increment to say that we have already printed the first letter of the alphabet. And then we go again, we print the B, and then we add 1 to it, it becomes 67. We turn it back into the character, which is C. We store, we increment to say that we have already printed the second letter of the alphabet, and then we continue like that until we go through all the 26 letters of the alphabet. It's pretty simple. So what you should remember here is the while loop has the while statement, the while keyword. It has a set of parentheses, and the expression that you put inside those parentheses must always evaluate to either true or false, and then it has a body which is defined by the opening and the closing curly brace. And make sure you always have some condition, something inside the loop that will make this condition to fail at some point. In this case, is the increment of the value x. Otherwise, your code will loop forever. Now that we understand the while loop, let's look at the do while loop. So I'm going to write another method here, public void test do while loop. And all right, there we have it. I'm going to do the same thing, but this time we're going to try to make it a little more interesting. But first, let's do something simple by counting maybe from 1 to 10 still, even though. Okay, actually this is the structure of the do while loop. You see, well, let me define my variable here, int x. I'll use this later on, I'll keep it there. Do then I would say while, and this, and I'll say while x is less than or equal to 10. What's happening here? What's up? Ah, I missed a curly brace. Sorry about that. Yeah. All right. Now, actually, you would see that when you're using the while loop, if this condition fails for the first time, for example, if I said x was equal to 27, for example, if I said x was equal to 27, for example, and I run this statement, you will see that it simply says we are done. We are back here. We are running this one, test while loop. You see that if I executed this with the value of x being 27, then I would never have gotten into this block of code, right? I would never have gotten into this block. I will never get into this block of code, and the code is never executed. But there are some times that you want to execute something at least once, or maybe you want to check for some value before you start looping. To make it easier here, I'll initialize the value 27. The value of this to 11, for example. Yeah, I'll initialize it to 11 since we are counting. Later on, we'll do the alphabet thing and we'll use 27. I'll initialize it to 11. I want to count from 1 to 10. But maybe this variable was used by some other part of the program and I'm not sure of what it contains at this point. So I could make a statement here that will force it to initialize, to reinitialize to 1. For example, I could say system.out.println, for example, and I'll say in do portion, in do section, for example, in the do section. And then maybe I would say x is equal to 1. Perfect. All right. Then down here, I'll say system.out.print. No, this would not be a good example. This would not be a good example. All right. Well, what I want to point out is the do while loop always executes the body, the do part first. And then after that, it's going to execute the while portion. I'm just going to go back initially to the original thing I had. I don't want to do that because it's going to reinitialize my value. So I have x equal to 1. And then down here, I would say system.out.println, and I would say x. Print me the value of x plus some space. Then I would instead use print, not print line. And then what's going to happen here is before this condition is ever tested, this portion will first of all execute. So the do while loop will first of all execute the body of the loop and then test the condition. Same thing with this one. Sorry, not the same thing, but it's the opposite of this one. It tests the condition. If it's true, it executes the body of the loop. So if this condition fails for the very first time, then it will never get here. But if this condition fails, then at least we will see that the value of x is printed at least once. So yeah, let me put it back to 11 and show you what I wanted to show you before. Now we want to count from 1 to 10, right? So what am I doing? I'm doing do. Like we said, it's first of all going to execute the body of the loop. And then after executing the body of the loop, what's going to happen? It's going to print out, it's going to test the condition. Now, if the condition satisfies, then it's going to go back again. That means if this evaluates to true, it's going to go back again and print the body of the loop and then test the condition. So it always prints the body of the loop before testing the condition. So if I run this, oh, sorry, I need to call the other method now that we just wrote, test do while loop. That's the one I need to call. And if I run this, you see it's printing 11. I have 11 here. Why? You see, x is 11, but x is not greater than 10. So you see, x is less than or equal to 10. This fails because x is 11 and 11 is not less than or equal to 10. 11 is greater than 10. And because of that, this condition fails. But you still see that this line was printed at least once, as opposed to the while loop where it first of all tested the condition before executing. So for the first time, if we had this as 27, it will never execute the loop even once. But there are times when you want to execute the loop at least once. Maybe you want to give a message to the user saying, hey, maybe you should enter the right parameter, like that. So you make sure that this portion executes at least once before the condition is tested. Now, if I change this to maybe 1, if I change this to 1 and I run it again, you would see that in action. Ouch, it's an infinite loop. Let me stop it. I have an infinite loop because I did not increment the value of x. So I'll just say x plus plus to make sure that it actually gets incremented, so that I have a condition that will cause this. I have a statement that will make this condition to fail at some point. Remember what I said about the infinite loop. So if I run this again, you see now that I have the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 printed out onto the console. Why is that? Because first of all, it starts printing and then it goes back to test the condition. So it prints here, it brings the value here, and then it executes this, and then before testing the condition, as opposed to when we had 11 here. Let's run it again. You see, we only had 11 printed out because it executed the body and it never executed for the second time because the condition failed. Immediately it executes this line, it gets to this point while x is less than equal to 20. What happens? It fails and it stops there. But at least it must always execute once. That's the difference between the do while loop and the while loop. The do while loop, the body is guaranteed to execute at least once because it executes the body before doing the test executing the test condition. But with the while loop, the test condition is always executed first before the body. The body will only be executed if it is true. Now you want to be careful about the structure of the do while loop. Look here, there is a semicolon. This is the only looping construct that you find a semicolon terminating it like this. Just to lay a little emphasis on that. And with that said, I'll recommend you go back, look at all of these again, try one or two things with them. Later on, we'll probably come back. We'll use the loops along the way. We'll use them often as we go digitally into the code, but we'll leave it at that for now. And in our next video, we're going to talk about nested loops, and then there we will see how you can use the break and the continuous statements to improve the way your loops work.